Good morning, ladies and gentlemen. I would like to thank the ICIMECE committee for the opportunity given to us to present our research. My name is Hartini. I am a lecturer at Department of Industrial Engineering in Diponegoro University. The research team's members consist of Yunda, Fiantika, and Yusuf Widharto. The title of our research is Optimal Treatment Combination for Liquid Soap based on this cooking oil according to the requirements of Indonesian quality standards. Introduction. More than 90% of households in Semarang City, Indonesia still throw away waste cooking oil and have not yet recycled. This amount is equivalent to 252,271 liters of waste cooking oil that are disposed of each year. Consuming waste cooking oil will endanger food safety and human health. However, if used cooking oil is thrown away, the waste cooking oil will damage the aquatic community. This study conducted a random survey in Semarang with 133 respondents. The result is 82% of the respondents prefer waste cooking oil to be processed into soap. 80% of the respondents choose the type of the soap over hand washing soap or bath soap. In this study, the most optimal kalium hydroxide concentration is obtained from the lowest concentration results. So it is necessary to measure the characteristic of the soap using a comparison of lower kalium hydroxide concentration than the results of previous studies, and then make a comparison to find out which formula is better. Research methods. Cooking oil used for the manufacture of dishwashing liquid soap is household cooking oil with 3 uses. The result of a questionnaire that was conducted to the Semarang City community concluded that the processing of this cooking oil is better processed in the dishwashing liquid soap with physical characteristic colored and smelled of herbal scents. The results of processing with cooking oil in the dishwashing soap will be tested by referring to the SNI quality standard on laundry soap. This study used a combination of manufacturing methods, purification material, and different base concentration that meet the SNI quality test standards for soap consisting of 3 parameters, namely free alkali levels, free fatty acid, and soap pH. The manufacturing methods consist cold method and the semi-boiling methods. The concentration of kalium hydroxide with concentration 22.5%, 25%, and 27%. The purification consists activated carbon and banana peels. This table is shown the combination of the treatment of making liquid soap from VCO. Purification of waste cooking oil. Waste cooking oil is purified before being used to mix soap. The steps of the purification process include filtering to separate dispensing and immersion process. Filtering is done using filter paper and soaking process using 7.5 grams of activated kepok and 100 grams of kepok banana peels as an adsorbent with 24 hours immersion time. Making dishwashing liquid soap. The making of this soap consists of 2 methods. The cold method is made by mixing 100 grams of waste cooking oil with kalium hydroxide concentration and stir using the hand blender for 45 minutes. After the water is added with a ratio of water soap 2 to 1. Stir again for 3 minutes, then add coloring and perfume as much as 2 milliliters. Then stir for 2 minutes. In the semi-boiling methods, the manufacturing process is the same as the cold method. The difference is waste cooking oil is preheated until it reaches a temperature of 55 degrees Celsius. Then mixed with kalium hydroxide with an oil ratio 2 to 1, kalium hydroxide. SNI parameters used to consist of pH, free alkali, and free fatty acids. pH measurement is carried out using a pH meter. Measurement of free alkali and free fatty acid is done by titration. The data obtained were analyzed using a normality test, homogeneity test, and univariate multi-way ANOVA test. Then proceed with two key tests at level 5%. Results and discussion. 1. Based on the results of the normality test, the homogeneity test, and the univariate multi-way ANOVA test showed that there were no significant difference between treatment combination. However, it was found that the semi-boiling method produced a higher pH than the cold method, and also the semi-boiling method produced higher kalium hydroxide concentration than cold method, so as a result, pH value also increased. 2. In pH testing, it was found that the kalium hydroxide concentration had a significant effect on pH. The higher the kalium hydroxide concentration, the higher the pH value of the resulting liquid soap. 25% of kalium hydroxide concentration produced the best soap with a pH value of 10.30, whereas in this study, the best kalium concentration was 22.5%, having a lower pH value of 8.77. 3. In the free alkaline parameters, it was found that the factor of kalium preparation method and concentration influence the value of free alkali content in the soap, where the semi-boiling method produces higher free alkali compared to the cold method, and the higher the kalium hydroxide concentration, the value of free alkali also increased. 4. In the free alkaline parameters, it was found that the factor of kalium preparation method and concentration influence the value of free alkali content in the soap. The effect of combination treatment on the pH of the soap. The average pH produced is between 8.97 to 9.33. The result of this study showed that the pH value was influenced by the method of making and kalium hydroxide concentration. The pH value in the cold method is lower than the semi-boiling method. The higher the kalium hydroxide concentration, the higher the pH value. This picture is shown the relationship between the treatment combination and pH level. The effect of combination treatment on free alkaline levels. The average free alkali produced is between 0.05% to 0.09%. The results showed that the value of free alkaline was influenced by the method of making and kalium hydroxide concentration. The free alkaline value in the cold method is lower than the semi-boiling method. This picture is shown the relationship between treatment combination and free alkali levels. The effect of combination on treatment of amount of free fatty acid. Average free fatty acid produced between 0.32% to 0.57%. The results showed that the value of free fatty acids was influenced by the method of preparation and purification. The value of free fatty acids in the cold method and activated carbon is lower than the semi-boiling method. The picture is shown a relationship between treatment combination and free fatty acid. Cost analysis. Production is assumed to be made by family welfare empowerment team, so it does not require labor costs. Product sales revenue for making dishwashing liquid soap per year is around 20 million Indonesian rupiahs with a capacity of 2,400 units. Conclusion. Our treatment combination had fulfilled the SNI WASH quality standard for SNI 0620481990. The pH value and free alkali content are influenced by a combination of treatment and kalium concentration. The best combination of treatment is A1B1C1. Cold preparation method 22.15% kalium hydroxide concentration, activated carbon purification material. With a pH value of 9, free alkaline 0.05 and free fatty acid 0.3. Further studies need to be carried out on the minimum and maximum limits of the composition of cooking oil soap making material soap. Thank you for your attention.